In the last few years, artificial intelligence has gone from sci-fi to everyday reality. Tools like ChatGPT can write essays, generate code, and hold surprisingly human-like conversations. It all feels a bit like magic, but at its core, AI isn't some mystical black box. It's built on surprisingly simple, elegant principles that we're going to demystify, starting with the very first building block, the artificial neuron. Think of an artificial neuron as a tiny decision-making unit. Inspired by the biological neurons in our own brains, its job is to receive some information, process it, and then pass on a signal. It's like a tiny switch that only turns on when certain conditions are met. Imagine a light switch. If you flip it, the light turns on. An artificial neuron is a bit more complex, but the core idea is the same. Each neuron takes one or more inputs, processes them through a simple mathematical function, and then produces an output. For example, if you're trying to decide whether to bring an umbrella, a rain neuron might take inputs like weather forecast says rain and sky is cloudy. If both are strong enough, it outputs, yes, bring an umbrella. This fundamental input processing output cycle is the bedrock of all AI. Now, one neuron isn't very smart on its own. The real power comes when you connect thousands or even millions of these neurons together into what we call a neural network. Imagine a vast, interconnected web where the output of one neuron becomes the input for another. This layered structure allows for much more complex processing, mimicking how different parts of our brain work together. But how does this network learn? It starts with something called neuramine biases. Think of weights as the strength of the connection between neurons. If a certain input is very important for a decision, its connection will have a high weight. Biases are like an extra nudge, helping a neuron activate more easily. Initially, these weights and biases are random, making the network's predictions terrible. This is where training comes in. We feed the network massive amounts of data, for example, thousands of images labeled cat or dog. The network makes a guess, and if it's wrong, we tell it how far off it was. This error signal is then used to slightly adjust the weights and biases throughout the network. It's a continuous process of trial and error, slowly refining the connections until the network becomes incredibly good at its task. When a neural network has many layers of these interconnected neurons, not just one or two, but dozens or even hundreds, we call it deep learning. Each layer learns to recognize different features. For instance, in an image recognition task, the first layer might detect edges. The next layer combines edges into shapes, and subsequent layers identify more complex features like eyes or ears. By the final layer, the network can recognize a whole object. The packed, deep learning also implies the need for truly enormous datasets. To learn effectively, these complex networks require millions, sometimes billions of examples. Think of all the photos on the internet, all the text in books, all the spoken words recorded. This vast ocean of data is what fuels AI's ability to identify intricate patterns that would be impossible for a human to manually program. This ability to process and learn from vast, complex data is why deep learning has revolutionized fields, from medical diagnosis to self-driving cars. It's not explicitly programmed with rules like, if you see 2 ears and a tail, it's a cat. Instead, it learns these rules implicitly by finding statistical correlations within the data, effectively building its own internal understanding of the world. So how do we get from recognizing cats to writing poetry, which is what large language models like ChatGPT do? The game changer was an architecture called the transformer. Introduced in 2017, transformers are particularly adept at understanding sequences, like words in a sentence. They can weigh the importance of every word in relation to every other word, even if they're far apart, something previous architecture struggled with. This attention mechanism allows transformers to grasp context and meaning in a way that feels almost human. When ChatGPT generates text, it's essentially predicting the next most probable word based on all the previous words and the vast amount of text it was trained on. It doesn't understand in a human sense, but it's incredibly good at pattern matching and generating coherent, relevant responses. ChatGPT and similar models are just incredibly scaled-up versions of these deep learning neural networks trained on truly astronomical amounts of text data from the internet. The sheer scale leads to emergent abilities that were hard to predict, making these models powerful tools for creativity, information retrieval, and problem solving. From simple neurons to complex conversational AI, it's all built on layers of mathematical sophistication. If you found this explanation helpful, please hit that subscribe button to keep learning about the future of tech.